Now we will transition, kind of picking up on Manolis's plugs for different research that is going on, to share some highlights and examples of some research and development opportunities that are going on. So I'd like to ask my co-founder at DXtera and the Chief Technology Officer, Jeff Merriman, to join us. He's going to be joined by Russ Shilling and Rich Silva, and they can all do their own introductions or their presentations, and we'll keep going on with our day. Thank you.
There we go. The green light. I'm Jeff Merriman, CTO and the other co-founder of DXtera. We're going to try to keep this brief. And one way I'm going to do this by not doing any slides, but I want you to remember Andrew's slides because they're really good. We met these guys not too long ago and started conversations and realized between sort of DXtera's philosophy for how we're dealing with data management, interoperability, integration, and whatnot, and what they're doing is really well aligned. So we're hoping to do more work with them. But a little background. So we've been working with our member institutions on developing reference implementations of data management stack of software to help higher education. We're focused on higher ed primarily. Get a handle on their data, do better, easier integrations, and then be able to use that data in various ways. And we do that with a common openly published domain model that is very similar to EdFi, which Education Analytics is closely involved with, but it's really focused on higher education. And what that allows us to do is work with organizations to sort of normalize the way they look at data, to think about and better connect data across different systems for the purposes of integration, supporting different kinds of applications, but also for doing data reporting and analytics. And a number of years ago, as we were standing up these systems at various colleges and universities, we sort of came to the realization that at these organizations, we're sitting on millions and millions of records about student success or non-success, out of SIS systems, out of LMS systems, and moving on to other kinds of systems. And we began to ask the question with our members, and these all sit within their secure, protected space, right? But we started asking the question, would there be ways to use this data or to open it up in some way for various kinds of uses? And we actually launched a community called the Open Authentic Data community within DXtera. That's what eventually led to the EdSAFE AI Alliance, because we began, as we looked at this question, we said, well, what do we know about this? What are the kinds of uses for this? AI came up, and I tend to group advanced analytics with AI as well. And the questions about how far could one go in this space became kind of that piece of the conversation. And we started looking at techniques, and Amy had her 4 boxes. We kind of looked at all that. And so there's places where you need real data, and you need to build protections and contractual agreements about how real data can be used. And there's places where you can create anonymized data or data simulations with enough noise so it's difficult to figure out any particular individual, and begin asking what's that data good for. You can even do totally random data. I mean, we have situations where we take real courses and programs, but then create simulated populations and randomize it and say, well, these students all took these courses and programs, but none of it makes sense. And we've been asking ourselves, well, is that even useful? Turns out it is. If what you're trying to do is do something like performance test issuing digital credentials to a blockchain, having a lot of data that looks real enough for that purpose is not bad. And then in between, you got things like homomorphic encryption, other sorts of technologies that one can bring to bear. So we actually began looking a little bit and doing a little bit of work in the simulation space. And we actually developed a funding proposal, an unsolicited grant that we submitted to IES that we believe was one of the sort of inputs that led to their RFI that kind of led to some of this. We didn't get the grant, but it led to a great conversation. Separately, we began looking at things like homomorphic encryption. What can we do there? So as I look at Andrew's slide, where he says, what might the future of longitudinal data systems be? We're very well aligned, because what we've sort of been saying is, how could we move from, in the case of statewide, longitudinal, SLDS to more of a SLDN? What does a statewide longitudinal network look like that's more focused on infrastructure? What does it mean for an organization to publish its data, to put together that train in different ways? So here's my train that I put together that's real data that I share with only special people who have a contractual agreement or some other protections in place. Here's the train I put together that says, well, here's what we're able to automatically create from real data that might be simulated, anonymized, and noised up in a way that it really can't be, where we protect privacy, but it might be useful for certain purposes. Here's the train I might put together using some really cool technology like homomorphic encryption or other sorts of technologies for other purposes under other rules of engagement. And that's kind of what we're thinking. We've only begun to do a little bit in the simulated data space and doing pretty bad simulations, which are very secure because there's no way to figure out who's who. But that's kind of where we're heading with that idea. And we actually met, was it yesterday or the day, very recently, where you brought this question up about what does the next generation of statewide longitudinal look like? And we heard from Mark today that there seems to be maybe an appetite for asking those questions. So I think we're thinking that for the things we care about, that is an area that I think we want to try to figure out how collectively we might be able to move forward and begin doing some interesting R&D projects, look for the kinds of resources to make that happen. So with that, I'm just going to pass it along to Rich.
Thanks, Jeff. My name's Rich Silva. I've been, actually, I was having some nice reminiscences earlier. I started my professional career, I taught public school in a different millennium, middle school and then high school, but I've been in higher ed for about 30 years now. And most recently, doing predictive analytics and adaptive learning with BayPath and some other institutions, and right now working with typically small footprint institutions to develop predictive analytics and adaptive learning methodologies and systems. And what Jeff was talking about in the ability to have access to larger data sets is going to be an absolute necessity to even begin this process with a lot of these smaller institutions, because by definition, the institutions with the small footprint, it's the exact opposite of massive data, right? When you start to look at the statistical numbers, you run into problems with N counts and statistical significance almost immediately. So the idea of having access to a much larger data set that you can mine in order to pull out data points that are potential predictors that you can then score and tune against an institution's specific data is incalculable. It's going to be the difference between them being able to apply this and not. What I keep coming back to, however, is this idea that predictive analytics is not a destination. It's really a launch point, because it's going to give you most schools are looking at it, they talk about an earlier warning system, right? They're going to give you access to do interventions. But that's really just the beginning, because first of all, what's interesting is that the things that we find as a result of predictive analytics work typically fall into a number of categories, only one of which is student behavior and performance. What you find is that you end up with things surfacing in institutions that are really more administrative and policy driven. So there's one institution where we had an issue where we found out that students that the earlier they registered for the upcoming term, the more likely they were to matriculate through to the end of the term, except that there were policies at the university that made it difficult for them to register early. So how do we apply that? Because that's not a student behavior issue. In fact, we're inhibiting success. There are other things that are just fascinating, but completely unobtainium. There's, well, students from this zip code tend to do better in math than students from this zip code. Well, that's fascinating and potentially a place for further research, but it's not like I'm going to suggest to the student that they move across town. And then being able to identify. But then you have, in addition to having this, dare I say, operational facility of producing your early alerts and sending out and doing your interventions, now the next phase begins, and it was referred to in the last session, of being able to design interventions and document the application of those interventions. So we have a predictive analytics score that says this student is subpar on their engagement with the discussions at a class. And we have an intervention that's designed to get them coming up to speed on discussions in class. Well, let's document that intervention and let's feed that back into this large data set, because where we're just beginning to see traction is this idea of using this technology for intervention analysis. Okay, we've sat down and says, well, we think we know what makes a student successful, but let's actually find out what makes a student successful. And now we need to say, well, we think we know what's going to help the student get over this problem, but let's find out what really helps the student get over this problem. And there's a massive opportunity for research. A colleague of mine, Dr. Jennifer Berry, just published an article about how counselors and advisors unintentionally introduce bias in the way they interpret the results of a predictive analytics system, and how that can be addressed potentially through professional development. So that's one area of research that is just beginning. Then you have this opportunity that if you built this predictive analytics data landscape properly, to turn it in different ways and do curriculum success analytics. How is our curriculum performing? The example I always use is we have 60 otherwise high-performing students that all seem to blow it in this one module, in this one math class. Probably not a student behavior problem. Maybe we need to put our instructional designers to work looking at what's going on with that module in the math stack. Dare I say, because this usually gets me shot at when I say this, you turn it on another axis and you can now, once we were saying what makes a student successful in the classroom, but if we look at this data from a different perspective, and Andrew knows where I'm going, we can say what makes the faculty member successful in this set. Again, we think we know what we're doing, but now we have the opportunity for evidence-based, and there are huge opportunities if we have access to the data to mine these and really come out with what are best practices around intervention, what are best practices around, faculty. And one specific example I can draw on is we were doing intervention analysis at BayPath around our staff, and everything is, it's a case in Salesforce with a reason and a reason detail, and we're able to aggregate all of that and analyze it. And we had an intervention called a math boot camp, and what that was if before you were on board, when you were onboarded, you did a self-assessment of what you thought maybe your pros and cons were, going to be. What were you concerned about? What were you concerned that you would be struggling with academically? And if you checked off that you had a concern that you might struggle with math, we made a suggestion that you go to math boot camp before you saddle up to math 110 or math 120. And what we looked at when we looked at the data initially is said, boy, this intervention doesn't seem to be doing anything. There's no lift from the boot camp. Oh, well, then let's not spend the money anymore. Well, the research opportunity is let's dig a little deeper into this. Let's bring the self-assessment onboarding data into the model and see what it has to tell us. And the conclusion that we drew, and this was published 3 years ago, Dr. David Demers and myself, was that what these students were self-identifying as a math deficiency, our conclusion was that it was in fact a math phobia, because their performance did not bear out their concern with their math proficiency. And if we hadn't have dug that deep layer down and said, hey, wait a minute, we're looking at this the wrong way, we might have thrown the baby out with the bathwater by eliminating the math boot camp, when that really wasn't the nature of what was going on. So the opportunities here, every time we peel a layer from the onion, we end up with more questions than we got answers in the first round or the second round. And for my money, and it is actually, this is how I make my money, is if you're getting more questions than you have answers, you're doing it right. And it should be an ever spiraling circle. And I think that we're just beginning to see what the possibilities are. And with access to these large data sets, potentially, we could really begin to get some very powerful results from this.
I'm Russ Shilling. I'm a senior advisor for the EdSAFE AI Alliance. I've got a fairly broad background, and I want to talk a little bit more about what Mark Schneider was discussing today about research methodologies and process. I'm an experimental psychologist by training. I came into the military in around 1993 and spent my military career looking at training, education, and psychological health research. The one thing that we haven't really discussed a lot today, and then this will all fit together as I go along, is the interoperability issues. And I think, one of the things we need to discuss on a research, from a research standpoint is, the basis of everything we should be doing, pushing ed tech at this point, should be looking at interoperability. Privacy, of course, is part of that process as well. But with all of these different data sets that we're dealing with, we're inhibiting ourselves on the civilian side by not discussing interoperability as much as we should. Program officers aren't, necessarily doing a good job of calling it out when they're putting an RFP out on the street. We need to get this solved so we can push ed tech forward in a broader context. One of the ways that I see that happening, my last tour of duty in the military was as a DARPA program manager. So I went from DARPA to the head of STEM at the Department of Education, and working on the ARPA Ed issues as well on the side. But one of the things we should think about is how we're structuring these research programs around ed tech. As Mark said, we probably do need to at least blow up a little bit of the research process at this point. And what I mean by that is, the traditional research foundations are pretty solid. They do good work, but we really need to look at interdisciplinary teams more and how we're funding them. So whereas the DARPA process doesn't map well necessarily to IES or other education areas, parts of it really do. And the part that does is this view of creating interdisciplinary teams of groups that don't normally play together. And that would include, making sure you have your privacy people, you have interoperability in the middle of this, all of these little pieces on the team that you as the program officer put together. And it's got to be more flexible than what we're funding today. So, in the DARPA model, not only are you a short timer, so I knew when I went to DARPA, I'd only have 3 to 4 years at most. If I didn't sell a program, 6 months is about the life cycle of a DARPA PM. So it's a hungry environment. You have to do a lot, and you have to move quickly and get a program together. But you've got these pieces, and if things aren't working out on the project, you get rid of the pieces that aren't working. So just because I've funded a program doesn't mean I'm going to finish the program if I find out it's not working. And just because I funded a company or an individual doesn't mean I'm going to stick with them through the whole project. So, it's a level of flexibility that it goes well beyond what we see on the current government models. I've been working on this for a while. So after I left the Department of Education, I worked with the Chan Zuckerberg Initiative, Digital Promise, and the Gates Foundation to create what is now called the EdSAFE program. So it's a math program that's being run and is now funded by CZI, Gates, and Walton. And we started building in these pieces into that program at the outset. And it seems to be going along pretty well, but it's a different model than what we're used to. There are some challenges to that. One is that, and Mark alluded to this on the challenges comment, the performers aren't necessarily comfortable with that model at the outset, or at all for that matter. And so you have to actually bring people along and educate them on the process and get their buy-in. On top of that, you have IP issues that you have to work out. I mean, there are lots of little pieces that you normally don't have to worry about on these more focused research programs. But at the end, you've got a full product at the end of whatever program you're running. And you can make sure that it's got all the pieces you need to go forward. Again, the interoperability piece, I think, is going to be critical for us. The military has done this not tremendously well, but they at least focus on it. So they have XAPI that they've used, before that SCORM. You know, interoperability has been at the forefront of military thinking because they want their simulations and training systems to be able to communicate. You know, I've had recent conversations with them. They could use a lot of help from the civilian community as well on data analytics, on engagement. There are things that I think we're doing better on the civilian side, but we need to be looking more generally across these different agencies and into DoD where there's, you know, a different mindset and different views of how AI is being used. But I can tell you, having talked to them recently, the DoD training folks are having as many problems figuring out what AI is and how to use it in their training systems as we are on the civilian side. So what I would call for is, again, kind of the push for more of these interdisciplinary programs to be funded, which IES appears to be pushing towards. We're getting some buy-in on the philanthropies, which is really good. I'm working on another program with Gates now on early childhood assessment, which is still is trying to bring in some of these issues as well. But it takes a lot of work, and it is a higher risk factor. For those of you who are in industry, I would say the same thing to you. This has a place in your thinking as well. For when you're putting together programs and projects, you know, you really need to be putting through some of these higher risk interdisciplinary programs, making sure that you have learning scientists, you've got data scientists, you've got, you know, the best AI programmers, obviously, but you've got these complete teams working on innovative solutions that might be a little more risky than what you're used to, but are going to be required if we are going to push the field forward. So with that, I'll toss it back.
Throw it open to any questions or comments. I might put Andrew on the spot, given the last thing. I think you've found that EdFi has really been a bit of a game changer as far as interoperability, but also providing a consistent domain model for the work you're doing. Whatever you want to talk about or...
Thank you. Yeah, I mean, to the last comment about interoperability, I agree. Like, interoperability is the only way forward here. Your call out to industry, I think, is right. Like, and if you're not thinking about interoperability, if instead you're in industry and you're thinking about siloing to monetize, you're in trouble. That's not going to work. And we're seeing a lot of that in K-12 right now, at least. I think with the EdFi interoperability piece in K-12, what we see is a single funder, in this case the Dell Foundation, has been funding that work for, I think, 12 years now and has committed to another 10. So that's a 25-year span where they have been hammering and hammering and hammering and trying to move the needle in one direction on interoperability. And that's the kind of effort that these things take. And they're finally getting traction on moving the needle in the industry so that the commercial field moves towards it. One thing that they did that I haven't seen anyone else do is they not only did data standards work and API standards work. They also built the software and said, here's what you implement. And that is a big difference between a lot of the other efforts that I've been involved in where we talk about specifications, we talk about data standards, et cetera. Here it is, implemented, it's got warts on it, let's work on it together. So, yeah.
Yeah, until we get that done, really, you know, we've been talking all day about all of these data sets and the privacy, but we really need to get the standards out there so that it's standardized, so we don't keep on having to redo this every couple of years. So.
Yeah. I think you do for the people on the call.
Yes, I'm Larry Fruits of the Access for Learning community, and we build a SIF standard. And you know, it's been 30 years, and there's other players out there. There's IMS, there's others. We're CDS, we're all supporting kind of thing. But standards are built differently as a governmental oversight. She mentioned Australia, how fast they can move things, the needle in Australia. They built their SIF standard in Australia, and so the government said, this is what we're using. So until a government's going to do that, my audience is different than the EdFi audience, is different than the IMS audience. Who we report to are all different. And you look at the schools interoperability, the SIF framework, it started at the K-12 level worried about operations. So we have bus transportation information, food service information, point of sales information, things that CEDS may never have or EdFi might not have in it. So there's a lot of different variations when we talk about use cases in K-12, which I've spent my whole life in K-12, either in the classroom, I was the state ed tech director in Ohio, but every lens is different when it comes to a use case. Some schools, if he has a use case and she has a use case, the exact same use case, he may need more help. That use case may hurt him in the future of what he wants to do because he has no infrastructure. You were talking about small schools. I had one school that had 8 students in it, K-12, an island school out in the middle of Lake Erie. So you got to worry about the big public schools who, number one, don't listen to their state agencies. The city schools have more resources than I ever had, staff or resources, and the little guys just tell me what to do. So you sort of have the ends of the spectrum when it comes. But standards is very tricky because you got different audiences building them differently. Ours is a little different than EdFi. We have an open process where everybody has to build it. I don't have a staff member to build it. They all build it together. It takes a lot longer, which people would like it faster. I'm sure they want EdFi changes faster too, but it's hard to get adoption, and then the vendors have to turn around and build to it. So that's the challenge. So if you're looking at K-12, where you talk about the state longitudinal data system, I reviewed, I helped the early ones of those. Those were initially built for a state to collect data from a school district to give to the federal government. It doesn't help the school district. I know school districts who put stuff in their state reporting system because they don't have the answer. And they'll make it up when it comes to that. So there's a lot of challenges in who's the ownership of what data when it comes to K-12. It's the wild, wild west. It still is, and it's going to be for a while. But you have to bring value, and Steve talked about the Student Data Privacy Initiative. That was value because they built it. It wasn't a system top-down approach, it was a bottom-up approach. So the more we can get vendors and schools collaborating on standards, no matter which one you can use, they're mapped, you can go between the standards, it's not a big issue. But picking one winner overall is going to wreak havoc longer than we need to. And I always said it was a professional failure of mine that we have so many of them, because we don't need too many more standards. A lot of vendors tell me we like more standards because that means there's no standards, which is a scary proposition. So it's a challenge what you're looking at. When you guys always talk about research, and that's my doctorals in research, is what research are you doing on whom? If you want the SLDS data, you're not getting school data from what the school needs. In particular, you need to go to the schools to get that school. So it's just an interesting, and that's the challenge of K-12, I guess.
Well, I think we're now past time. Dale has approached the podium.
Without a dance this time.